Hi, my name is Sabrina. So I'm going to explain about the training error. This is the equation that represents the training error. And this equation will we will get this graph by using this equation if we plot. So we can just ignore the first upper graph over here. Okay. So let's say if we have a smaller value of d, let's say if the d is equal to 1, so it will actually correspond to this graph where we will get a very simple graph, and the value of the error will become higher because it depends on this graph. And as we move to the right where the value of d become higher or larger, let's say the value of d is equal to 100, so this will correspond to this graph where we will get a more complex function, and the value of the error is over here where it is lower than the value of the error when d is equal to 1. So we can conclude that if the value of degree of polynomial is higher, so the value of error will be lower. And if the value of the degree of polynomial is lower, the value of the error will be higher.
Assalamualaikum, I'm Afika Azman and I will explain about UteM tutorial question 2. Okay, as you can see that this is a diagnosis bias versus variance, which is the x is referring for degree polynomial d and the y-axis is referring for the error. So the problem for this diagnosing bias versus variance is based on variance problem. Why? Because if algorithm is in high variance, which is this, the train error will be low. So the cause of this will be overfitting and the hypothesis will not be fit. What can I be conclude for this tutorial? When the degree of polynomial is increased, the training data will be fit too well in algorithm. So the training error will be decreased. As the y, if the highest degree polynomial, the training will be better. The sign of overfitting problem is occur when it have a high problem. The training set accuracy will be increased and the cross validation error will be set accuracy to be poor. If the parameter of d increase, it will be overfit, which the value of cross validation can be increased. So this is the mean of the d parameter. So that's all from me. Thank you.
My name is Dina Armanila. I want to explain about the question of tutor 3 in week 10. Before I started, I want to introduce these two equations, which is the first equation is h theta x, which is this equation namely as model, and the second equation is j theta. This equation namely as learning algorithm objective. In this j theta equation, it has a regularization term. This regularization term is used to prevent overfitting and to keep the value of parameter to be small. Next, I will explain about this one of the case, which is underfit. In underfit, it uses a very large value of regularization parameter, which is lambda, For example, lambda is equal to 10,000. Once the lambda is equal to 10,000, all the parameter, for example, theta 1, theta 2, theta 3, and theta 4 are having heavily penalized. When it has penalized, it will end up the parameter will be approximately or equal to or close to 0. Once the parameters is close to 0, therefore these four term in this equation will be cancelled since the value is times with 0. Therefore, the hypothesis will only left h theta x equals to theta 0. When the value of lambda is large, it will done regularization. In this equation, j theta, the regularization term will not minimize the squared error since the lambda is large. Then the underfit setting will be like this, which is it has a horizontal straight line. The horizontal straight line is not a good model for dataset. This hypothesis has high bias and badly underfit, and this underfit might not fit the training set well. That's all from me. Thank you.